Hi, I'm Avisha Das. I'm from the University of Houston, Department of Computer Science, and today I'll be presenting my paper on the automated email generation for targeted attacks using natural language. I would like to start by providing some insight into how social engineering attacks, especially phishing attacks, take place. So we usually define a person's digital identity as his or her unique information on the internet by which he or she can be identified on the internet. So, in a typical attack scenario, a fisher usually disguises himself as a legitimate entity and then sends a malicious link embedded in a common attack vector. For example, in this case, it may be an email or an chat message or an SMS message, and these attack vectors are embedded with poisoned links, usually, or maybe malware attachments, and then the unknowing victim looks at these legitimate looking emails and then may fall for the deception and thus puts himself or herself at risk. We present a brief overview of our presentation, and we start with our motivation, and then we'll go into our approach and our architecture of our automated email generation, and then we finally present our results and our evaluation. So, what is an active attacker challenge? So, in the field of security, research usually follows a very reactive trend. That is, the patches or the fixes are usually proposed after the attack has been identified. What is more desirable is an approach which is more proactive in nature, wherein one can easily identify, or one can identify a probable future attack, and then kind of create an attack based on the common current trends, that is emulate an attacker, and then once if the attack is successful, the researcher can then go ahead and propose a solution or a defense mechanism to the attack. One such sophisticated attack type is email masquerading attack. So in such a scenario, what you would assume is that an attacker has gained access to a certain Mr. X's mailbox. He can then access all the emails that Mr. X has received or has sent. He also has access to the email IDs and the contacts in Mr. X's trusted network. In an email masquerading attack, what the attacker would try to do is he would look at the emails that Mr. X has written, the emails that he has sent or he has received, and then he would try to emulate or copy the writing style of Mr. X, and then send emails from his mailbox to the people in his network. Here is an example of an attack that I personally faced. So one of my friends, usually we don't talk via emails, but suddenly, like one fine morning, I saw an email from him which said that, hello, did you receive the list of items that I sent earlier to you, and that he has re-uploaded some items to Google Drive, and he has sent me a link to Google Drive so that I can click on that link and go to Drive and see. It somewhat seemed a little bit off and little bit fake to me, and so I went ahead and looked at the original text, and I saw that the links that were embedded under the tag Google Drive or click here were usually not Google Drive links. They started with http googledrive.com. Usually the links that are shared that link to your Google Drive start with drive.google.com. So this was a classic example or a perfect example of an email masquerading attack, and this attack was so sophisticated that my Gmail webmail like classifier, Gmail Google Safe browsing couldn't actually catch the attack. So usually in an email masquerading attack, what the attackers would do is he or she would try to manually compose an email by emulating the writing style of the target's email inbox who he or she has hacked into. So what they would do is they would emulate the writing styles, and then try to manually write deceptive emails which they would send to the victims. And what we're trying to say is that in such a case, this is it involves a lot of manual labor and it's time consuming. So what if we put an AI to use in such a case? So in case of an AI, the attacker would train an AI on the type on the various types of emails that Mr. X usually writes, and basically the AI be would recognize or create a pattern which is similar to the writing style of Mr. X, and then try to generate emails by emulating the writing style or the stylistic features that are common in Mr. X's emails. So there are two advantages of such a method. It would help the attacker expedite the process of email generation. He can now launch large scale yet sophisticated attacks using his trained AI. There have been two natural language generation systems for fake email generation, which have been proposed before. One of them is a grammar-based system. The authors used a recursive translation network to generate grammar of a legitimate email structure, and then using that grammar, they would generate fake emails. And this would require a manual construction of email grammar, which is around 3 hours of effort. And if the attacker has to emulate different types of writing styles and different types of writing styles of different people, it would like multiply the labor and the time. And moreover, the usefulness, or as we are going to see later, the usefulness or the efficacy of such generated fake emails is not that useful, is not that great. The second type of email generation system that we saw was stochastic email generation, where the author would also manually identify the topic structure and the sender style in a legitimate email body, and then generate emails using manually created rules. So we will go into the details of our approach. We used a deep neural network with an input layer, word embedding based input layer, multiple hidden layers, and then our output layer, which would generate the email or generate the text based on the input words. As you can see, deep neural network would have an input layer, and then it would have multiple hidden layers in between, and then which may be fully connected or may not be fully connected. We considered a fully connected network, and then an output layer, which is the final layer. In this case, in the given figure, you can see that it distinguishes between an instance, whether it's a red or a blue instance, and in our case, it was mostly generating like given a word, it would generate the another word which has the highest probability of accompanying the given word. So we used a recurrent neural network for our text generation model, to build our text generation model. What the beauty of an RNN is that it's capable of learning long-term dependencies, and thereby making it capable of learning a better representation of textual content on which it is trained. For our purpose, we used a sophisticated version of RNN, which is an LSTM, to build a sequence-to-sequence learning model on our word embeddings, and which in this case is our input. And our model consists of 3 LSTM layers, each with 256 hidden units or nodes. We used two types of data sets for building our model. Our legitimate data sets had a total of 603 emails, which were collected from Hillary Clinton and Sarah Palin emails, which were leaked, which are publicly available, and also, as well as emails from the Enron corpus. The malicious data set was a little bit larger, and we considered Nazario's corpus of phishing emails, as well as phishing emails collected that we collected ourselves. And had a total of around 2,300 emails. We also compare our generated emails with certain around 12 synthetic emails that were generated by the author of paper 1 here, and to see how our model, how our fake emails differ from a proposed system of fake generated emails. So I would go into a little bit description of our text generation and sampling phases. So in our generation phase, we input words into our trained model, and then it outputs the most probable word that can follow the given word. In this case, you can see that if we want to generate a text of T words, consisting of T words, we would input words starting from word W0 to WT-1, and then it would build a model, a probabilistic model consisting of all the words, all the T-1 words, and then finally generate the WT word. In our sampling phase, we used a parameter called temperature for our output generation. Our temperature parameter is very unique, and it helps to control the output or the nature of the text that our model is generating. So using the temperature parameter, we would try to control the novelty of the text, or novelty or the eccentricity of the text that we are generating. So it was a challenge to manipulate the value of temperature, so that we have the perfect trade-off between a perfect or an optimistic trade-off between like some sensical and nonsensical text. So as you can see from the equations, that our probability model, the model actually builds a probability distribution based on the input words, and then we use softmax normalization to get the final set of output, which uses temperature control to kind of select the words or that it would generate. So if we have higher temperature values, then the text is more stochastic, that it by which we mean that it generates more diverse type of text, but it makes a lot of mistakes because it tries to be more imaginative, more innovative, or more creative in the text that it generates. But if we go for a lower temperature value, then it would make the text more deterministic. That is, the model is more conservative. It tries to make less mistakes in the generated output, but in such a case, there is a high probability or a high chance of the model repeating the number of words that it generates, or we see a lot of repetitive words in the generated output. One of the major challenges was the automatic injection or automatic generation of malicious intent in the generated or fake emails. So we had to come up with a way of injecting automatically some malicious intent in the form of malicious cues, like a poison link to the malicious website or a malware attachment or something, so that these links or these attachments or some words, some some words would be evident or would appear in the generated or the fake email that our model is creating. So the main key is to wrap the harmful intent or the malicious cues in legitimate context so that it can evade detection. We uh, we we use a percentage based influx of malicious content to model or to train our model. So to emulate the stylistic features, we feed our training model some ample amounts of both legitimate and malicious data. We created separate models trained on legitimate emails, and then we also created models which would have a mix of legitimate emails as well as around 5% of malicious emails, which were uh, which were around 120 malicious emails. Then we would we would change or we would vary the percentage of the malicious emails or malicious content that our model was seeing from starting from 5% to 10%, 30% to 50% to 70%. And we generated a variety of emails based on those training models, various types of training models. So a few of the email generation examples that you can see from here are when we trained a model only on legitimate emails, we could see that there were not many malicious cues that in the generated text. Uh, and when we tried to when we started injecting a little bit like of the malicious content like bit by bit, we'd see that when we had around 600 legitimates and around 120 malicious emails, our trained model would then generate some malicious cues that you can see are marked in red in the second example. And then what we did was in the higher models where we have around 600 legitimates but more malicious emails, like for example when we have 50% of malicious emails, we have around 1150 malicious emails and around 600 legitimate emails. That is like the malicious is around twice the size of the legitimates. We see more of the red or the malicious cues appearing in the final generated text. Here in the examples, we while before training our model, we actually pre-processed our data to include more like to remove all the named entities and make it more generic. We removed the links that were occurring with the link tag and the various named entities with the NET tag. Then we went ahead and trained some detection algorithms on some legitimate or like labeled legitimate and phishing emails, and then we also created a test set with 100 legitimate emails and 25 fake or generated emails, and then we saw how these existing statistical detectors would perform on the fake or generated emails that our model had created. So we extracted some very fast and common textual features like document term matrix and word count vector features, and you can see that the best classifier, which is the logistic regression classifier, had an accuracy of 91%. As I had stated earlier, we had around 100 in our test set. We had around 100 legitimate emails and 25 fake emails. So you can see that out of the fake emails, the logistic regression classifier kind of could classify or could identify correctly 20 emails, but it's still like 5 emails, which is like around uh, 5 emails actually kind of deceived our classifier or evaded our classifier detection. So we can see that despite the incoherent nature of the fake emails, our trained models actually fails to achieve 100% accuracy. We were expecting that it would achieve 100% accuracy, but it actually could not. So we went ahead and compared our generated emails with a baseline, and as you can see, the one example on the top is a fake email generated by the data engine, which is actually like a grammar based engine, and you can see that it has no malicious cues. But in our example, we can see that we generated, or we could successfully include some malicious cues and some malicious words and textual features in the generated email that our system would like gave as an output. We went ahead and did an error analysis of our system, and we saw that there were two types of errors which we observed. So from our trained model, we saw that at a lower temperature value, around zero point 0.3 or zero point 0.4, we would see that our model would generate a lot of repetitive text. This is definitely an issue about the temperature value, but also we should keep in mind that we need to cut down on the amount of and there needs to be some kind of some sophistication in the type of text that we are feeding our model while training. And we also saw that we also looked at the misclassification of fake emails during our quantitative evaluation, and saw that like if there are a lot of words, or if the length of the text is a little bit longer, then it kind of evades simple statistical detectors. So to conclude our presentation, I would like to say that we actually tried to prove how a simplistic deep neural network model, which is very easy to create and very easy to launch, can be used to automate and launch sophisticated email masquerading attacks. We also compared our synthesized email with previously proposed um, fake email generators, and saw that our model was much more successful in generating emails with malicious cues or malicious signals. And we also model a deception, or the deceptive behavior of our attack vector by passing it through certain statistical detectors which failed to achieve 100% accuracy in detecting detecting our fake emails. I would like to end my presentation here. I thank you all for your patience. If you have any questions, you can ask my colleague here, or you can also drop me drop me an email, or contact me at my email address, or you can look me up on my website. Thank you.